Hello, welcome. Thank you, Julia, for the great talk. I really enjoyed that. Okay, so I'm Patrick Sukop. I'm a security consultant at Base Information Security, based in Portugal. You can find me there on Twitter and GitHub. Look at some of my resources that I've made, contributed to. Today I'm going to be talking about the cost of fixing security vulnerabilities in each phase of security life cycle. So this applies to if you're involved in the project management, if you are in the DevOps, if you are a developer, team lead, wherever you are, this will apply to you. So just for a little icebreaker, those I read while I was reading SQL injection on line 32. So what is this SDLC I speak of? So we have the start of a project, first phase. Second phase, requirements and gathering of information. Next phase, analysis. Moving on to design, development, testing, deployment, operations, and maintenance. This is extended. You guys can shorten this. You can combine phases together if you want. It's all depending on the company. So just a quick little overview. So I forgot to mention, if you guys have questions, please ask immediately because it's important that you guys understand each slide as I move. If you don't understand the previous slide, you might just get lost a little bit. So now that you understand the software development lifecycle, you know of it, what does this mean? So we're going to focus more on the design, the development, the testing, deployment, operations. So these, because that's where vulnerabilities are implemented or introduced into software. You can't have SQL injection implemented in the documentation in Analyze, for example. It doesn't make sense. So where are defects introduced? The majority of the vulnerabilities are introduced in the coding phase. Why is that? Because the developer is writing, he's the person who goes and copies some code from GitHub, or GitLab, Stack Overflow. You don't know what he had. So he doesn't, some client comes and they want some advanced functionality. The developer might be not capable of doing it. So a friend comes and the friend doesn't know better, or the developer isn't educated in terms of security, and you have 75% of the vulnerabilities introduced. But you still have vulnerabilities implemented later on, and that is because after your testing, you have it goes back to the client and they don't like one of the functionalities or that introduce something. Scope creeping, I'm sure we're all familiar with that. The developer then has to go introduce more code, and there we go, there's a vulnerability. Cool, everybody understand that? So where are the defects discovered in the software development lifecycle? So you can see that the defects are introduced when testing starts, and they get stopped after system testing. Obviously, because who's looking for the bugs? No one testing and past testing, everything's done there. But it's not zero. You can see that there is still some vulnerabilities in the release. Why is that? You have a client who phones you, says, hi, I've just managed to access another client's information. Boom, there's a vulnerability. Or maybe you have a bug bounty. You never know. So vulnerabilities could be introduced later on. So the cost of fixing the defects. Okay, this is dependent, reputational risk. Risk according to the application, is it a critical system? It is all dependent. But we do know that it is exponential. So why is it exponential? How many people are involved in the coding phase? How many? Yes. The developer, the development team. You don't have the system admin or the database engineer going in the coding phase. It's not even in QA, it's not in production, it's not in UAT. So it's all on the local host of the developer. So we have one person, a small team. Not a lot of time, labor is expensive, but yeah, you have one person. Then we move over to the next phase, unit test. You go now to unit testing, there's a vulnerability. You have to go back one phase to coding, fix those vulnerabilities. That could be time. The developer has to go to Stack Overflow, copy some more code, and then go again for unit testing. Now we've involved 20 people into this life cycle. We have to pay for their time, we have to pay for their lunch, we have to pay for everything. So we 4x. Now we go to functional testing. Again, more people involved, more systems involved, more time involved. So it goes more. This is where it gets exciting. System testing. So we follow on. We have more people from coding, unit testing, functional testing, and now system tests. We have to pay for everything. If there's a vulnerability, we have to go back all the way to phase one and go, and go, and go. And then with the release, reputational impact, reputational risk. It all depends on the organization again, but it could cost. You could do so many clients because of something like that. It all depends as well on the system. Maybe the system got breached. Maybe the system is sending other clients information. You don't know. But then you have to go back to coding, unit testing, functional testing, system testing, and release. But guys, we're talking about this in a few seconds. How long does it take for a system to get to release? How many projects actually hit the deadline? How many projects go over by a year? So now you have to go all the way back from the beginning, fix something, and start the phase by phase by phase by phase again until you actually get it right. So, do you guys understand this? It's going to get really complex now. How many of you guys know and understand what the term shifting left actually is? How many of you have heard of this? Let's just say this. No? Yes? Nothing? Okay. So, how do we fix this? To secure software development lifecycle, we fix everything earlier on in the phase. We shift left. You can see we actually shift everything now left. So now, how many of you guys have heard of shifting left? No? Not everyone? Okay, sorry. So we shift left. We try to pick up the vulnerabilities from the developer. You could pick up all the vulnerabilities from the developer and fix it right then and then. You would have such a smooth process throughout the software development lifecycle. The process of going from unit test, functional test, system test will be such a breeze. If the server admin, database admin all know what they're doing, it is much easier, it is much quicker. You don't have to go back from system tests and then coding, unit test, functional test, system test. It is a smooth process. So, how do we get there? Oh, sorry, comparison. So, if we educate the developer and we properly do our unit test, our functional test and everything, and we pick up the vulnerabilities, the defects earlier on the life cycle, you can see that the cost here is much less because we're fixing the vulnerabilities, we're discovering the vulnerabilities much earlier. So we don't have to go back 1, 2, 3 phases. We pick it up here, we go back 1, 2 phases. So it is quicker. You don't have to go coding, unit test, functional test, system test, back to coding. Because you might have it, we have to do that repeat after month, week on week, every phase. You have to go back and you go back. So shift left, educate the developers, use source code reviews, stuff like that we'll get to now. So how do we do this? So does everybody understand that previous slide? Any questions? Sure, this one. Last chance. Okay. There's a review after this to say. Okay, so how do we do this? We've identified, we understand shifting left, we know what it means. In a very high overview. We're not going to go into huge detail. Our next talk will, I'm sure, we'll touch a lot of it, and that's where most of the questions probably come. But in the information gathering phase, how do we better shift left? How do we introduce a secure software development lifecycle? Cool. We have, from the beginning, a security analysis, security threat modeling. From the design phase, we have a security test plan. From the development, we educate the developer. We show the developer OWASP top 10. What is it? We give him resources. We help him because the vulnerabilities start with him in that application. On that first line, IDE, we introduced a nice plugin. I'm a C# developer, so there's a cool thing called PumaScan. It's open source, it's free. You install it into your IDE, and when the developer builds it, pops up saying, hi, there's SQL injection on line 32. You've got a buffer overflow on this line. You've got everything there. So right in and then, he knows from when he develops and builds the application, he knows where the vulnerabilities are. Source code review, manual. Have a senior developer go through the code. Maybe even use a tool called Bugs, which will go through all the whole solution and find certain keywords that might be vulnerable. And then a security white box testing. In the testing phase, have a penetration test, do security black box testing, and a vulnerability scanning. Nessus is a great tool. There's a lot of open source applications that also do that kind of function. Deployments, impact of analysis of patches is very crucial. So we might get to the last phase of the development lifecycle, and now Nginx has an RCE, remote code execution. What is you going to do? How long are you going to take to patch that critical bug? This needs to be done because the longer you wait, the more likely you are to be compromised or to introduce these risks. So this isn't just for external applications. Everybody has critical applications running inside their company. It could be developed in-house, externally, but you can still stop it. External applications, before you deploy it, you can pen test it. You can run it through a static DLL scanner. You can do all of these things. You have control. When you implement this, the only person to blame at the end of the day is you because you didn't do the proper steps. How many people know that you can do these kind of things before that? How many people have actually asked for the pen test report or the security assessment of the application of an external app before implementing it in their business? Not a lot of people do that because the education isn't there. People aren't aware of that. So, yeah. Questions? Guess that's a good talk. Yes, my question. So, it's not fair. You know more about this, more years experience than me. I'm sorry.
White box security testing, exactly. And then at the same time, we're mentioning black box security testing as like another step. But the one thing that I was wondering is like, where do you see the advantages in doing actual black box testing when you put out white box testing available by the same people?
Does everybody know the difference between white box and black box? Does anybody want to go over that? No? Okay. So white box testing is great in terms of, instead of I'm going to use a web application that accepts a parameter in the search function. Instead of you spending 5 hours going and actually testing the application, you can actually look at the source code and be like, okay, this is compromised, this has reflected cross-site scripting. Right then and then you fix it. But at the end of the day, with the black box test, it's nice because you can have automated tools that go and spend the whole evening just reinforcing certain things, trying new approaches that you're aware of. In the CLI pipeline, maybe you have something there that you just know and test something. Nessus capabilities. Nessus doesn't know exactly what the source code is, but we'll go and try things with you like that. But it's just that extra step. The majority of the phases the majority of our runs will pick up in a white box assessment, white box, because if it's done properly, because it's easy to see reflective proper scripting, SQL injection, deserialization, etc. It's just to add that extra step.
So, gotcha. So basically, what you're saying is like in this step, these things that you don't really need the black box information for.
Well, you might have it that you in that black box approach, you automate it and you download a Python script that tests something that's not even heard of. It's just right there and then, hey, I tried it, notes my code is great, it can go to the next step.
Good talk.
Thank you.
So I'm guessing those numbers are for more traditionally siloed companies and teams where you actually are throwing stuff around and you have very slow release cycles.
No, this can be like, are you talking about more agile waterfall approach? Are you talking
kind of a more, well, I guess when I get the question, I'll be a little clearer, but so for teams that have very quick release cycles, very short, they're not putting out small amounts of code. They have a lot of CI/CD for testing, unit testing, bulk scanning, and stuff like that. So there's less people that have to touch everything. That's when more vulnerabilities are, because you're going to push out quicker. Not one particular, it's being pushed out quicker. You should have this with 3 people in the team. More likely the better. You have one guy who deploys it, one person who just does the source code review. And what's nice, again, we're talking about with the white box approach, you have the people scan that know the source code, they look at it and say, okay, cool, SQL injection, before it even gets to the next phase. So when the guys building it, when it takes build, right in the it starts. So there's a notification that you have boom done, thank you. And then the next stage, more of black box approach would be the source code review. The guys looking, cool, good, we'll show you new changes. You don't have to go through 3,000 lines of code, you just go to the code that has been changed. If not, you can apply this with 2-man teams, you can apply this with a 1,000-man team. That's really, for me, that's no excuse. This works with inside team. You have the tools there, you have open source, you have commercial products, enterprise licenses. It's definitely possible. AWS, make this a dream for you. Even if you're using Kubernetes, it's still, there are tools out there. There are so many people pushing forward toward the SDLC. It's amazing. The open source community. You can't say, I use Kubernetes, so I can't use this. Never. Bullshit. You can use this. Just gotta get it integrated.
Exactly. Yes, exactly. Yes, my next door goes to Jeff about this. Please, the order of 10 questions with him.
The security conference just last week, where this was one of the main topics. So, how to combine nature development in conjunction with security operations, security processes, and pushing that was one of the main things that was mentioned there as a potential matter. The question I have is if there are any, if you have done this in practice, have seen this in practice, because as we know, there aren't many security specialists around. There aren't many people around that are interested in becoming security specialists or being trained to be security specialists. So pushing that is a nice idea, but getting people there that actually find security issues before the testing starts might be difficult. So do we have some data on how this works, or if this actually works in practice, or it's just theory?
You want to say something more about AWS and
AWS, what I wanted to mention about was CIC. So the manual process of
okay, let's get this out. Numbers about DSA you see all this. So let's get to the phases quickly, just to better explain. So again, you need to understand that you can stop the vulnerability earlier on in the phases, right? Here we go, in those phases. Through threat modeling, and that's where you have more people that have to be more specialized. You need to understand how to do threat modeling, right? If the developer doesn't know how to do threat modeling, you need to start from like activity, all of that. So if you can, and I've seen it, educate at the development phase with the having these pivot scans, having the developer understand what a vulnerability is, having him understand what SQL injection is. I've seen it prevent a starting shift left to left because the developer will go, okay, but I understand what's top 10 now. I know it, I've seen it in PHP, I've seen it in whatever program you're programming in, and now I have more questions about it. So then they will go to management, or there's that I wanted to learn. So then we'll start more early on. Or the developer might say, you coming to me and you want me to store credit card information. Even before development, you design now. The developer is like, no, this isn't going to happen. So now you're going back a page, just by educating the developer, you're saying, okay, spending money, spending resources at the development phase, you're really going back a phase by doing nothing. So yes, I have seen it, it does work, but it is expensive if you haven't started from the beginning, and it does take a lot of time. You have to be very patient. Some companies, when they hire developers, in their contract say, you write secure code, so they get breached. They say, you wrote this, we have proof that you wrote this, here's your fine to warning. And then he starts to say, okay, they're taking this seriously. It shows them other developers, okay, I need to know what I'm doing. Is that approach, which I don't agree with, but there's many ways you can do it. A lot of companies are starting to do. They are implementing a developer phase because when you find a team leader that knows security, you're not going to. When you have the marketing department want you just to implement WordPress because it's nice and fancy, you're not going to have a marketing department knowing about security. So I've seen it, but they started in development phase. They want to version. Okay, cool. Let's do
So in this entire SDLC life cycle, they came by testing with BDS. What should you do with that?
White box, black box.
Let's just call it white box. Being an internal employee of the organization,
black box.
I think it's to clarify what's the first and play that scene because I think it's very explainable.
Vulnerability assessments both of them can be automated, but vulnerability assessment is a list of vulnerabilities that are likely to impact your application. So I'm using WordPress version 1 and there's WordPress version 12. That's a vulnerability assessment. What can I do with this vulnerability, etc. Am I getting it right? Yes, I'm getting it right. Then pen testing is a more in-depth review. So you break up it into white box, black box, and it's a more hands-on approach. So you want to go fuzzing every query, looking at how the application handles certain inputs, interaction and integration of application with other systems, stuff like that. That's my understanding. Yeah? Yes?
That's more to it. It's more than application. So it also depends on infrastructure.
Yes.
So
yes.
the application is running on Apache,
Yes.
whatever web server. The Apache might have a vulnerability that might cause your application to be vulnerable.
These applications that I see all of that. Yes. So you still have the question. Which phase? I think the best phase is for me before deployments. If the company is shifted there. Okay. Because you will get more value out of it for me, more risk. Because imagine if you shift it everywhere there, we ended up just before development and we pick up at the SQL injection, we know you're not developing, you're not using secure outside development, we can pick up exactly where it's gone wrong. Oh, okay, the developer doesn't know what SQL injection is. Your thoughts? Or would you get your testers?
I'm just thinking about the redundancies. External libraries that are getting installed and deployed because it interacts with other environment things, right? So should we consider that as kind of investing or focus on the local code, the developers.
So we talking about more particular node, yes.
Like full throttle pen testing, let's just talk about it.
That actually stops at the development phase.
Mm-hmm.
Even before it gets to certain testing or a release, it shouldn't be there because the developer needs to go, I need this library. Okay, let me check when the last is updated. Right then, it's updated 3 years ago, not using it. Done.
It's the main difference between vulnerability scanning and the white box testing, because vulnerability scanning, that's where what you can do when you try it. So looking, okay, which current version of which library you're installing, is it outdated or not? Because that can change in the meantime when you're actually running the application. Something that you look at, especially because you actually can't change things there. You won't develop some library yourself just because there's vulnerability there. And typically, if you have a library that's well developed, it would be too much of a burden to also find vulnerabilities in the library as well. It's not take that to most applications. And white box testing is relevant because it has to go there. We should find the vulnerabilities as early as possible, and the vulnerability scanning should be done in production or before production in negative production.
Your question was the layout problem.
So my question is that this applies very well if you are developing application and with Terraform and Svelte, now infrastructure is becoming the scope. So what's your take on this? Can this be applied when you are developing infrastructure with Terraform configuration? Because there are no related tests for this. People just think like a configure change and save some delays.
It goes again back to the related system defense system.
Yeah, we actually develop the infrastructure, and that's what I was targeted and working on. So we are developing software for the infrastructure, and that's where we do white box testing that we will develop. One of our main assets is actually our vulnerability scanning, because we do that regularly, actually dating over our whole infrastructure. And manual also is automated, of course. So we actually just define stuff that shall be scanned, and then we get the regular report. And well, typically, even if you do the infrastructure scope, you should do that because it's really nice. You can just read what all there's in a little bit of vulnerability. Typically, you won't develop the actual recipes or playbooks or whatever yourself for most applications, but we take a ready-made playbook or whatever, Gantt chart, whatever you pick. So we actually won't fix the things in there. You might find problems and then try to fix them upstream, but most of the time it will be the Gantt chart of the actual developer of the software. And that's the standard that we should do. Patches as well. Well, patches, of course, but it's more about the configuration that you're rolling out. And as I said, so typically these configurations are well tested, either by the developer itself of the software or by the community. How else can we improve the recipes? And that's what we should be discovered.
Just because scanning is more like after the deployment or maybe not as environment. So just wondering like we can cover more steps, etc. Like now the infrastructure engineer is right in the lecture. Cool. Yeah, we highlight some vulnerabilities there, like something like that instead of just like maybe vulnerability scanning.
Well, you have to distinguish between two things. So one thing being is a problem with the software you're deploying, or the version of the software you're deploying. That's what you can actually check within the CI pipeline. So you can just take your image, just build and then check the versions within the image. And the other problem that you can have is the configuration. So the integration of problems coming from the configuration that you deploy. the two steps that you can do. The first one being CI/CD again, so just setting up the test environment where you will spin up the infrastructure that you just configured and having standardized tests. Depending on whether you can find tests that are worth executing. And the other thing is then actually doing vulnerability scaling against production.
So during this session, is there any, I know we have questions, if it's genuine questions, we can go. We're all passionate about the same subject, right? So let's just take a little bit more space to.
I have a general comment. Everything this is all nice, like it really works in the slide, it's everything, but I think like the real world problem is how do you sell this to the management? Obviously, this is cost a lot. You need security people, you need to educate, you have to send them to very expensive trainings. Security trainings are very expensive. Plus, from project start to deployment time, we have a lot of startups here in Berlin when we're competing against a lot of other startups, and you have an idea, you want to deploy it super fast, and now we have like a business team coming in and needs time to do something, it takes how to find kind of a balance in there. Like, is there like a minimum viable?
No, so there's a point here. So again, reputational risk is such a new thing. For me, it's very difficult to put the price on that, for example. At the end of the day, the client is paying. So imagine you have this beautiful website. Somebody finds that you take the cost of scripting and boom, you've got horrible images on the website, which is the only place you find clients. Waiting for the event to breach the managers and other top managers are coming after you, stuff like that. So it's about saying, using case studies previously, in any sort of industry, there's a case study. You look at like Samsung, the X7, I think, that when reports are live, they followed this model, and not the vulnerabilities, but the defects, that will save so much money, in information security, breaches, there's so many other things, there's case studies. History repeats itself, and you can use that to talk to Andrew. The cost of educating a developer is nowhere close, in my opinion, to the cost of reputational risk. Nowhere close. Last question.
It's not a question per se, but just answering some of the questions of my feedback on some of those comments on some of the topics. So about CI/CD, right? So in CI/CD itself, there are a lot of projects which can help you automate most of these checks. So the ones which you have on your developers, of course, you have a lot of ones which you can integrate on your IDEs, but then you also have, so for example, SonarQube. That's not a free product, but it's a paid product.
It's great.
Yeah, it's a great product because it checks your code quality, not just how good your code is, but also checks your vulnerabilities in the code. So it checks about all of those, and it doesn't even create a release artifacts which can be even moved. So depending on how strict your guidelines are, you stop it right there and then. Exactly. So it doesn't even go to production. So, and ideally, you're supposed to have a staging environment. So, as part of your deployment, you're supposed to have a staging deployment also before your actual production deployment. So, that's where you're supposed to do your vulnerability analysis, and all of those. So, all of those are supposed to be on the staging environment and not on the. Because you can be like Netflix and do it on production too. If you want to be the chaos monkey and all that, yes, we'll go all for that. But otherwise, you're supposed to have a staging environment where you can check most of these things, and before it goes into production. So, and all of these can be configured in your CI/CD. Infrastructure as code. There's also GitHub projects. So there are a lot of OAuth projects which are open source, which can actually do complete automated security testing of your application. Exactly. And they will create a durable report for you which says that, hey, your application is vulnerable to this. For infrastructure as code, also there are a few open source projects which actually checks the infrastructure to see if there are any well-known vulnerabilities inside your infrastructure. Do you have packages or applications installed, nothing to do with your software applications, but packages installed which might be vulnerable. So it can do a lot of this for you as part, and you can integrate this with your CI/CD pretty much with much less effort than if you had to write it by yourself.
Yeah, and it's fully automated. You can automate it, which is great as well.
Exactly.
Less time and labor.
Correct.
Cool. Thank you, guys.